In a previous video, we looked at a problem where vectors were added together, and we solved that problem using a trigonometric analysis of the vectors. In this video, we're going to look at another example that we can solve using trigonometric analysis of vectors, but this time there's going to be a vector subtraction. So here's the problem. A hiker must walk to a spring which is 7 miles from the base camp in the direction 20 degrees south of east. So let's put the base camp at the origin here. Okay, so there's the base camp. And the hiker has to walk to that spring 7 miles from the base camp in the direction 20 degrees south of east. So let's figure out where that spring is. So first, let's mark the direction 20 degrees south of east. And I hope you are following along with your own protractor and straight edge. Okay, so I marked 20 degrees. So this is 20 degrees. Whoops. So let me draw on that line. Okay, so this is 20 degrees south of east. And the spring is 7 miles from the base camp in the direction 20 degrees south of east. So I'm going to go in and measure off the 7 miles. Okay, so let's put the spring here. And then let's draw a displacement vector going from the base camp to the spring. I'm going to call this vector C. It is 7 miles in the direction 20 degrees south of east. Now, what's going to happen is that the hiker is going to head off in the wrong direction. The hiker mistakenly walks 5 miles in the direction 20 degrees north of east. So let's measure off that direction. So 20 degrees north of east would mean we start out facing east and then turn 20 degrees to the north. Let's find 20 degrees north of east. That would be here. Okay, so that's 20 degrees north of east. Now we're going to measure off 5 miles in that direction. Okay, so the idea is that the hiker was supposed to start at the base camp and head this way, but instead the hiker walks 5 miles in this direction and then ends up here. Now, at this point, the hiker realizes his mistake and realizes that he's going to have to start from here and go over to the spring. That's going to be the second displacement that the hiker needs to make. And then the question is, when the hiker goes on that second displacement, how far and in what direction does the hiker have to travel to get to the spring? Okay, so let's call that first erroneous displacement that the hiker made A. And then that second displacement that the hiker has to make to then get to the spring, we'll call that B. And what we're trying to solve for in this problem is the vector B here. So we want to start out trying to understand how vector A, vector B, and vector C are related to each other. And what I'd like you to try and do here is just pause the video. And as the video is paused, see if you can figure out which of these three vectors is the sum of the other two. Okay, so I hope you remembered that the way to tell that two vectors are being added together is to look for the tip-to-tail connection. And we can see the tip-to-tail connection here, right? Here you see the tip of vector A touching the tail of vector B. That means that these two vectors are being added together to make vector C. So I'm going to write vector A plus vector B equals vector C. Now, what we're trying to solve for here is vector B. so let's solve for vector B by moving A to the other side where it picks up a minus sign. We now have vector B equals vector C minus vector A. All right. So how are we going to solve for vector B? Well, if vector B equals vector C minus vector A, then the x component of vector B equals the x component of C minus the x component of A, and the y component of B equals the y component of C minus the y component of A. So here's what we're going to do. We're going to look at vector A by itself and find its x and y components. We're then going to look at vector C by itself and find its x and y components. And then we can put those together to find the x and y components of vector B. And then once we have the x and y components of vector B, we can put those together to find the magnitude and direction of that final displacement. All right, so let's find the x and y components of vector A. Okay, so to find the x and y components of vector A, let's just draw vector A on its own coordinate axes. Oops, x component, y component, here's vector A. So we have 20 degrees and then 5 miles. And then here we have the x component of A. And here we have the y component of A. Now, at this point, I would encourage you to pause the video and see if you can work out the x and y components of vector A on your own. Okay, so to get the x and y components of vector A, we're going to use the quickie method, in which we write down the components of a vector just by, first of all, putting plus or minus, then the magnitude, then a sine or a cosine. So for the x component of vector A, you can see that that's going to be a positive component because vector A projects onto the plus x direction. So I'm going to put a plus sign, although you don't really have to put that. And then I'm going to put the magnitude, 5 miles. Now I put either a sine or a cosine. The angle we're using here is the 20-degree angle, and a sub x is adjacent to the 20-degree angle, so I'm going to put cosine 20. And then for a sub y, same process. You can see that a projects onto the positive y-axis, so I put a plus sign, then the magnitude, 5 miles. And now that a sub y here, this would also be a sub y over here, right? These are the same. And here you can see that a sub y is opposite to the 20-degree angle. So I'm going to put sine 20. Okay, so at this point, you can put these into your calculator. And I get a sub x equals 4.70 miles. And a sub y equals 1.71 miles. All right, now let's go to vector C. And I would encourage you, before watching what I do next, see if you can go through the entire process for vector C on your own before you look at how I do it. All right, now let's find vector C. So we're going to give vector C its own coordinate axes. So x-axis, y-axis. Vector C in here. Magnitude 7 miles. Makes a 20-degree angle with the plus x direction. It is 20 degrees below the plus x direction. So now we can project vector c onto the coordinate axes. So we get c sub x here. C sub y here. Now we want to write down expressions for the x and y components of vector c. So same as before, for each component, we're going to write down a plus or a minus, then the magnitude of the vector, then a sine or a cosine. Now, c sub x, you can see it lies on the plus x-axis. So I can put a plus sign, or you can leave it out if you like. Then I put the magnitude, which is 7 miles. And then you can see that c sub x is adjacent to the 20-degree angle, so I'm going to use a cosine. Okay, now as for c sub y, you can see that c sub y lies along the minus y direction. So I'm going to put a minus sign, and then 7 miles. Okay. Now, as for the sine or cosine, if this is c sub y here, I can say that this segment over here is also c sub y. So here you can see c sub y lying opposite the 20-degree angle. So I'm going to put in sine 20. Okay, so now that we have these expressions, you can put those into your calculator. And you get c sub x equals 6.58 miles. C sub y equals minus 2.39 miles. Okay, so now let's start wrapping up the problem. Remember, the reason we were doing this is that we were looking for vector b in the original figure, and we have the x component and the y component of vector b expressed in terms of the x and y components of vectors c and a. So now that we have worked out the x and y components of vectors c and a, we can use this to put everything together to get the x and y components of b. Okay, so we have b sub x equals cx minus ax. Substituting our results from before, cx 6.58 miles, ax 4.70 miles. So when we do the subtraction, we get bx equals 1.88 miles. Okay, now with b sub y equals cy minus ay. So cy was minus 2.39 miles, minus ay, which was 1.71 miles. And we get by equals minus 4.10 miles. Okay, so now we have the x and y components of vector b. And now we can put everything together and find the magnitude and direction of vector b. Now let's put this together to find the magnitude and direction of vector b. And for this, I'm going to draw yet one more clean coordinate system. Whoops, a little smudge. Okay, so we have x-axis, the east direction, plus y-axis to the north. And then we have west, south. And now let's draw in vector b. So the x component is 1.88 miles, so we can mark that along the plus x direction, somewhere like that. And then we have the y component, minus 4.1. That would be in here somewhere. Okay, so now we can draw vector B finally. Okay, so this would be vector B. And now we would like to find the magnitude and direction of this displacement that the hiker had to go through to get to the spring after realizing his error. Now, as far as the magnitude, we can just use the Pythagorean theorem. So the magnitude of vector B would be the x component of B squared plus the y component of B squared and then square root. Now let's make our substitutions. We have 1.88 miles squared plus minus 4.10 miles squared and then square root. This gives us 4.51 miles. Okay, now we'd like to find this direction in here. Now, the first thing we might think of is setting up a calculation with an arctangent, but then we have this awkward question of the y component being negative. So as I've done in some previous calculations, I like to sidestep that issue by drawing in a geometric triangle where the hypotenuse of the triangle coincides with vector B. So now if I just take that geometric triangle and copy it off to the side, and a geometric triangle will always have positive lengths for its sides. So the length of this side here would be 1.88 miles. The length of this side would be 4.10 miles. Then we have the angle theta in here. And because we're looking at this geometric triangle, we can just say tangent theta equals opposite over adjacent. So 4.10 miles divided by 1.88 miles. And the inverse tangent will give you 65.4 degrees. Okay, so this direction that the hiker went in for his second displacement, we would say this is 65.4 degrees south of east, right? So to face into this direction, the hiker would start out facing east and then turn 65.4 degrees to the south. So this would be 65.4 degrees south of east. And if we want to take all of this information and put it into a single statement, we can say that at the end of the process, the hiker must travel 4.51 miles in a direction 65.4 degrees south of east.